Welcome all to my 13th lecture. In this lecture, we will see the advanced C topics, void pointer and function pointer. So first of all, what is a void pointer? Void pointer is a special pointer which holds the address of any data type variable. So it can hold the address of any data type variable. Let it be an integer, character, uh, structure, union, whatever the data type, it can store the address of any data type variable. While assigning the address to the pointer variable, we shall assign the address directly. So whenever you want to store the address to a pointer variable, you can just store it. But whenever you want to dereference the pointer, we should typecast the pointer variable. So let's try to understand this with some examples. I'll try to take the VS Code. So let's say that you are having some variable X variable. Let's assume that you are having a void pointer, right? So you should also give the star sign, void pointer, right? So now let's assume that you want to just store the address of X. Then yeah, you can just do this. So it's a straight process. So the pointer can store uh, the address of any data type variable. So X is an unsigned 16-bit integer. It can store the data, right? Now, when you want to dereference the pointer, you want to do the typecasting. So what is typecasting? So you should tell the compiler that set please consider this pointer variable as 16-bit pointer variable, right? So that is what you're trying to do the typecasting, right? Then when you want to dereference the pointer, then you put the star operation, which we have discussed in our previous video, right? So this unsigned 16 star, this means we are trying to, or we are saying that typecast, right? Typecast means we are forcefully saying the compiler, please consider this particular variable as a 16-bit pointer variable, right? Now let's assume that you want to have different different variable. Assume that you are having a structure. Let's try to use some elements as well, right? And now let's say that it's number. Then here we are creating number. Num is the pattern, right? So num is a user-defined data type. Num is a variable of number type, right? So now let's assume that the same void pointer or the same pointer want to store the address of this particular data variable, right? So now you want to send this, right? So we are just storing the address of num data variable to a pointer. Can do that. Now when you want to dereference the pointer, first you want to do the typecasting. So what is the typecast? So you should say now this pointer variable should be considered as a number data type which is of number based, right? So now what you want to do is you just mention number star. So we are typecasting. Then we are having a pointer, all right? And if you really want to dereference it, then basically you should dereference up, right? So this also will work, right? So what we are trying to do here is this number star is nothing but the typecasting, right? So we are doing the typecast here, right? Now, like this pointer variable, you assign the address as num. Then you cannot, uh, do, you cannot do this, say that this, please consider this as a 16-bit pointer, right? Now immediately the compiler will say that it's a wrong data type, right? So we have done the typecasting and then dereferencing. Means the pointer variable having some address, so we should try to dereference that pointer first. So that is the reason why I try to dereference the pointer first, and then I put outside a bracket to access the element n1. Then you are trying to pass the value as 10. So in the same way, you can have any variable which is of any data type. You can initially store the address to the void pointer, then you can use the same pointer, right? So whenever you have some application where you don't want to use multiple pointers, you want to use the same pointer for, so and so reasons, then you can have a single pointer variable which will, take the address of different data types at different points of time, right? Because pointer also needs some address location, right? Which also we have discussed in our previous lecture. So now let's try to also take some more examples to have more grip. Let's assume that you want to use this uh, void pointer as an as a special integrator data type. So I think it's straightforward. So we already have this integrator structure which consists of 4 different variables. What I will do is I will just try to quickly create a variable called integrator, right, with some voltage. Now, if I want to like uh, call this integrator function, what I can do is I can just take the pointer and I can pass the address of voltage. I can very well do that, right? And then if I have this integrator function, I can, now I can pass this uh, pointer, right? Now let's uh, define the function, integrator function. So now what we have done is like, okay, you are having a pointer, like, yeah, you can pass the, directly, you don't want to have this pointer as well, you can just pass this address. So address always has to pass to some pointer. But we are saying that it's a void pointer, means we don't know what is the pointer data type which is you're sending, right? So you passed a void pointer, right? Now you want to, what are the input signal? Like you are trying to do a typecasting. We are saying that it is a pointer, but it is of a type integrator. So it's a pointer to an integrator, right? So that is what typecasting means. Now you are trying to say it's integrator. You are trying to take another pointer variable called as the signal. And then you are trying to pass your uh, input signal. You're trying to pass the, so now inherently what we are trying to do is we will trying to pass signal will have a address of voltage variable. Is what we, right? Then standard integrator operation which we have discussed in one of our previous example. So you want to have the previous output signal multiplied with sampling time into input signal value. Then you want to store the present signal value to the previous, and then you can return the uh, present output signal to the integrator function, right? So now if you want to just have a, let's assume that in place of this, if you want to have a, pointer example with a first order low pass filter, now let's assume that you have a different structure, right? So nothing you want to do, like maybe the expression will be different because the example is of some low pass filter. Now what you have to do is you want to just typecast a variable to a different data type, right? So that is what we are trying to do over here. So this is also another example where you are trying to use a void pointer, right? So this is the application of void pointer. Void pointer is used when you want to use the same pointer variable to store the address of different data type variables. Now let's talk about function pointer. So function pointer, I will see it's a pointer that stores the address of a function. So as of till now, whatever we have seen is a pointer variable which will store the address of some data type, right? Or some variable. Let it be a structure, union, integer, char. It will try to store the address of a variable, but here a function pointer is a pointer that stores the address of a function. We shall pass a function as an argument to a function and shall be called afterwards and referred as a callback as well, right? So how will you do a normal function pointer? So to do a normal function pointer, uh, so normally what you'll do is, let's try to delete all these example. Maybe let's yeah. So normally what you'll do is you will say it's typed of, right? So now let's take maybe I think we have uh, let's try to let's try to pass the and itself. So what I'll do is and consists of so what you like unsigned 16 as a return data type. So what I'll do is like this, and then we'll have a pointer, right? And then the like stuff uh, 216. So I just try to use the 216 bit variable. So here we are trying to say it's a function pointer. The moment when you see typed of bracket, then basically you can understand that this is a function pointer, right? Now what you can do is you can just like pass the address of, right? Or sorry, I think you should first, yeah, like you should try to create, you should try to create the uh, like a variable called as point, which is of data type pointer. So this pointer is nothing but a function pointer, and then you are trying to pass the address of and to this point variable, right? So then inherently once it now when you want to call this function, right? The point, what you want to just do is point, right? Then pass the 2 comma 3. So that are the two variables. Like then what you can do is you can have a function definition for the and, right? So we can say return plus y plus y, right? Then yeah, you can you can say inside sum, and then you can you can just sum. That's all. So that's the beauty of like function pointer. Now let's assume that in place of addition you want to do subtraction, right? Let's assume that you want to do a subtraction. Then what you want to do is you want to declare the function as well. So I just declare this function. What I'll do is I'll just pass now point to a different uh, you know, like a different function. I will try to store the address of a different function. So that is nothing but sub. Now what I'll do is like if I want to have do the subtraction, now you try to do a subtraction, right? So we have used the same point like pointer to have a function pointer, and this is function pointer is so the data, whatever the address, whatever you're passing, that function should be of the same data type, right? So the add consists of unsigned two unsigned variables as an argument, and one one void or one return unsigned 16. So you should have a function pointer is also should be of the same data type. So that is the prerequisite what you have, and then you can use the function pointer. So So this is what the purpose of the function pointer is. So yeah, so I think yeah, you can see another example is like function pointer as a callback. So you can see you can pass the if you try to see the this particular line perform 5 3 add. So the function itself you can pass as an argument. So this function, whenever you are passing, it should have, we are passing to a function pointer, and then inside the function pointer we can call this function, operation, which is basically having an address of and, right? So the and is again defined over here. So this is like a function pointer as a callback. So this is also, you can very well do that, right? So this is another, like a little bit another topic. Let's assume that if you want to have a function pointer inside a structure, so what you'll do is, okay, everything remains same. So you have a function pointer, but inside a structure, you are saying that you're having a pointer function based. One of the element is pointer function data type. You created the variable as point. Now what you want to do is inside the main, you just want to store test dot point, right? So the test is a variable dot point. So the dot point, now it is a function pointer, so it should store the address of some function. So you are trying to say that we are trying to store the address of an ant, right? The element inside the structure is of function pointer data type. This data type should hold the address of a function, which is a type pointer function, right? So this is what I try to explain. So hope you have enjoyed my 13 days lecture. So if you have really liked my content, please like and subscribe my videos. I'll try to post some interesting lectures, which is normally uh, available generally, but I'll try to consolidate and try to share the knowledge. So my motivation is to share my knowledge, give something back to the society. Hope you have enjoyed this series. Thank you all. See you all in the next video series. Thank you.